viewers, welcome back to TechNerd, and this is a tutorial video for teardown, right? Teardown of our relay. So this is what we call relay. You can see that it has totally 1, 2, 3, 4, 5 terminals. So relay consists 5 terminals in which these two will be going to coil. Before going to relay, we'll see what's the block diagram of relay. Okay, so you can see here, this is our block diagram of relay, in which these two terminals goes to power supply, that is plus 5 volts, which in turn goes to coil, which generates magnetic field on apply of power. And this is a pole terminal. This is the third terminal, which is known as pole, and the remaining two are normally closed and normally open. This pole is when we consider these two terminals, then these two are normally closed. Means when there is no power supply, this will be closed like this. You can see here, when the power is applied, the magnetic field generates, and this switch goes from here to here. At that time, this NO, normally open, becomes normally closed, and normally closed become normally open when we apply power. If we don't apply any power, then this is normally closed, this is normally open. Now how to determine whether which is normally open and which is normally closed in our relay? So here we have totally 5 number of switch terminals, right? 1, 2, 3, 4, 5. So basically we can say that these two are for power supply and this might be our pole. So now we are confused that which one is normally open and which one is normally closed. So in order to find that, we can use our multimeter, that is here. We can use this multimeter. So let us switch to this, that is what we call buzzer, continuity checker. After shifting to that, take your relay and place it on one on any one of the terminal and another on pole. So we can't hear any sound, right? No sound. So that is we can say that this terminal might be our normally open. So if we place this same circuit, same terminals on the other pin, that is one pole and another one, this one. So this time also we can't hear a sound, means there might be something right. So actually those two are not terminals, they might be power supply. These two terminals are power supply. So this is normally open, and when we consider this one, this terminal and this terminal, I can't hold it properly, so let us hold in a reverse condition. You can see that, you can hear the sound, right? So this terminal is normally closed and this terminal is normally open, because we can't hear any sound when we attach these two terminals, and when we attach these two terminals we can hear a sound, beep sound. And these two terminals are power supply. How we can say that these two are power supply? If we connect these two, this will be showing, buzzer will beep. Okay, you can see here. Wait a moment. All right, you can see some values over there, right? On the screen you can see some values. That means that there is a coil in between these that measures some resistance. Because of that we can't hear any sound, but the values are changed to 67, right? So now let us supply some power to this power supply terminals. So I connected positive terminal to one end and a negative terminal to another end. When I touch this, you can hear click sound, right? Yeah, you can see. At this time when I supply some power, normally closed become normally open and normally open becomes normally closed, vice versa. Okay, now let us see what's the tear down of this relay. So in order to tear down, we need nipper, right? This is a nipper circuit, which can be used to cut the things. And this additional, we have this nose plier in order to hold and do stuff. Okay, so with the help of this we'll try whether we can nip it off or not. Okay, I just removed it. Yeah, right. Okay, now you can focus. So now we can see the thing inside. Yeah, so this is what exactly what's there inside. So you can see that this is a coil, right? This is coil, which is one terminal of the coil is connected to this. You can see the small thin wire over here. So one terminal is connected here and the other terminal is connected to this terminal, and then this becomes pole. So here you can see that a magnet kind of thing is attached over here, this plate kind of thing. Then whenever this coil is magnetized, then this switch will go down like this, right? When this switch goes down, this will be short circuited, means this terminal and this terminal. So normally open will become normally closed and normally closed will become normally open. So you can see from here, now this switch is attached from here, right? Here you can see. Can I close, take a bit closer? Okay, so last is this. So you can see that this is a small switch. Okay, so the upper part is connected to this terminal, means this terminal is normally closed because this is now upward, right? So whenever we give a supply of 5 volts, this terminal will go down and the bottom terminal is connected to this end. Bottom part of metal is connected to this terminal. So this is normally open and this is normally closed, because you can see here whenever the power supply is supplied, this will come down. Okay, let us see what happens when we give some power. So just I connected one terminal to one end and the another terminal to another end. So now focus, can you focus more? All right. So when we connect here, you can see that came down, right? So this is a simple philosophy behind it. When you supply some power, it will come down and normally open become normally closed and normally closed become normally open.